Oh boy, this question. An ideal spring of length L is attached to a ceiling and hangs vertically. A block is attached to the bottom of the spring, pulled downward, and release. The length of the spring as a block oscillates, varies between 1 meters and 1.1 meters. The maximum acceleration of the block is measured to be 2 meters per second squared. Which of the following is most nearly the length L of the spring? Now let's look at the period equation of the spring. That was really weird. Okay. We realize that this is the period equation of the spring, and if you follow the whatever, equation for simple harmonic motion, right? You get this, and then if you like go into Hooke's law and you look at it, we get F equals to negative kx. Hence, ma is negative kx, so a is negative k over mx. And you realize that this corresponds to this, right? So that's how we derive the period equation, but I just want to make sure you guys understand this. So we have k over m. Please stop. All right, so now that we have this, we can basically look back at our question. So if the block oscillates from 1 meter to 1.10 meters, we basically can find the midpoint because it is an ideal spring by doing this divided by 2. And by doing this, we get 0.05 meters. So the equilibrium point is going to be 1.00 meters plus 0.05 meters is equal to 1.005 meters. Please stop it, Google. And this is basically like the equilibrium length that the spring extends. And you realize that the formula we had earlier was A equals to K over mx. And we have A as 2 meters per second squared. And we have X as 0.05 meters because that's like the length that it goes. Yeah, okay. So we have 2 equals to K over M, 0.05 meters. And we can now solve for K, where K is now 2m over 0.05. Now we can go back to Hooke's law, where F equals to negative kx. Because F equals to negative kx, we also know that at its equilibrium point, which is 1.05 meters, the only force on it is going to be kinetic energy, and gravitational potential energy is going to be 0. Hence, all the force from F, like at 1.05 equilibrium point, is going to be caused by gravity. So it's going to be mg is equal to negative kx. Now, we can basically solve for x, where we have mg over k is x. So because we have mg over k, let's just 9.8, or it's physics, you round everything off, so let's just say it's 10. And we can substitute k as this term we have, so we have 2m over 0.05. If you do all the funny math, this cancels out, and you have 10 divided by 2.05, and you get 0.25. Because we are using the midpoint as the value that the force is only going to come from gravity, where again kinetic energy is maximized and gravitational potential energy is 0, we can substitute this back in, which is going to be the length of the spring plus 0.25 meters must be equivalent to 1.05 as the midpoint. Hence, L is going to be 1.05 meters minus 0.25 meters, which is going to be 0.80 meters. And you will find that this corresponds to answer B.